Genetically modified organisms, or GMOs, have been around for decades now, yet the debate over them rages on. So I want to know, are they really okay for the planet and for us as humans to eat them, or should we be worried? And if they are okay, why do some countries still not allow them? To find out, we're going to head on over to Ireland. 180 years ago, this country was hit by the Great Irish Famine, the biggest disaster in Irish history. It was caused by blight, which damaged the potato crops, making the potatoes inedible. Now, at that time, potatoes were the main or only food source for many of the people. So with no potatoes and no relief programs, 1 million people died, and a further 1.5 million were forced to leave their country just to survive. Both of Dave's great-great-grandfathers were arrested for stealing during the famine and were shipped from this port as convicts to Australia. One of them was only 15 years old. This disaster highlights our dependence on reliable crops to be able to have food to eat. So I've come here to teagasc, the Agriculture and Food Development Authority in Ireland, to ask Dr. Ewan Mullins, the head of the Crop Science Department, all of my questions. To start with, can you explain what is potato blight? Is it a fungus that seems to be different on every website I look on?
Technically it's called an oomycete, which for the person on the street, it effectively does pretty much what a fungus does.
Right.
The most important thing is that it destroys the plants that it affects. It hasn't gone away, it's still here, and it's global.
How is it currently being treated?
This is the conundrum. At the moment, the dominant treatment for late blight is using fungicides. If the weather is optimum for the disease, the pressure on the farmer is huge. They can't afford to miss what we call a spray window. And that spray windows could be as tight as every 4 to 5 days. Typically 6 to 7 days.
Yeah.
But if they miss a spray window in a typical spray program, so in Ireland about 12 to 13 sprays per growing season,
Wow.
which is a huge amount of fungicide. But if they do get in and they start to infect, it can be quite difficult to control it. Of course, the best way to control it is disease resistance.
And how long have people been trying to breed a just naturally selective breed of potato plant?
Yeah, so potato is a very complex genetic system. It has 4 copies of every gene. We as humans only have 2, so technically it's doubly more complex than we are. And as a result of that, it typically takes about 13 years to breed a new potato varieties. So it's a very intensive process, logistics, expensive. The fungicide chemistry has been extremely effective in controlling late blight for decades, basically. And as a result of that, the efforts to breed resistance has probably lagged behind. There's no farmer who likes to spray. So if there's any alternatives there, they're obviously going to take that if those alternatives are economically sustainable. And at the moment, there aren't any strong breeding varieties out there that would have resistance to late blight.
Many years ago now, you did some research on genetically modifying potatoes. Can you tell us about that?
Using an approach called cisgenics, you can cut a gene from a wild potato and transfer it into a conventional potato. Okay. Now you can cross the wild with the conventional, but you're looking at a lot longer than 13 years because you're mixing all the genes up from the wild in with the conventional. So you'll get the trait you want, resistance, but you'll get a pile of traits that you don't want, and that will mean the potato will be inedible, basically.
And when you say cisgenics, can you explain that for people who aren't familiar with cisgenics, transgenics?
Yeah, absolutely. So cisgenics is taking a gene from, say, a wild apple, putting it into a conventional apple, or from a wild potato to conventional potato. Transgenics is something that is not going to happen naturally. So transgenics is taking a gene from a fish and putting it into a carrot. We received the potato from a partner in the Netherlands. They had done the development, and our work was to look at the environmental impact in the fields. And there was no negative benefits to insects above the ground or indeed below the ground. What we saw was that the study reduced the spraying from 13 sprays down to a single spray in a common year.
Because it was effective, are they currently being grown in the EU?
No, they're not.
And what's the reason?
So, yes, back in 2001, Europe had a directive which was basically a process to assess anything that was genetically modified. That would take many, many years and was quite costly to anybody who wanted to put a variety through that process to be sanctioned for approval for cultivation or anything like that.
Is that still going to be the case, or is there any change in process?
So there has been changes in the last couple of years. The science was assessed, and EFSA published several conclusions and reports, and those reports showed that there was no greater risk using these approaches to breed new varieties, whatever varieties they were to be, and was equivalent to conventional breeding. So there's a lot of hope that actually in a matter of maybe months, maybe in another year, that these techniques would be considered equivalent to conventional breeding techniques.
If I actually wanted to modify something, so take like that beautiful flavour from an old apple and put it into a current one, how do I do that? And how long does that take?
How does it take? Okay. So the traditional way is you take pollen from one flower of the wild and you stick it onto the stamen of another flower on the conventional. You take the seed, which are in the middle of the apple, you grow it up, and probably 5-8 years you might have some fruit. And you cut it open and you see and you taste it, is it going to be any good? Chances are you'll have to go through thousands of progeny to find one that might give you some of the traits that you want. So with precision breeding, you would have to sequence the genome of the wild apple first, because you need to know what you're dealing with, okay? You need to know the blueprint, the genetic blueprint. So you sequence that genome, and then you need somebody who's very smart who can make sense of all that information. Okay, and when they do that, they can hopefully then begin to identify, okay, you're looking for a trait that is maybe nicer skin finish or slightly, dare I say, more bitter flavour rather than a very sweet flavour. And then you would say, well, look, okay, these two genes look like to be likely candidates for that. Okay, so then you can use editing. You literally snip those genes out and you pop them into the cells of the conventional variety using a bacteria called agrobacterium. So agrobacterium is a natural bacteria that infects trees. If you ever see a growth or a tumour sitting on the side of a tree that doesn't look right, that's caused by agrobacterium. And then you grow those cells up into a new plant, and there you go.
So obviously there's sort of two sides with genetically modified foods. The reason I've chosen you to ask these questions to is you're not one of the chemical companies that's going to profit from making seeds and patenting them or making money from it. So can I run you through some of the against arguments, and then you let us know which ones are misinformation, which ones might have some truth to them. Firstly, one of the ones you see a lot online on videos is GMO is going to cause cancer.
For all who eat them. When tested on rats, genetically modified foods cause them to develop horrifying tumors and other related diseases.
I assume that's referring to a specific study.
A very old one.
A very, very old one that was debunked multiple times by the community. Should never have been published. And it was unfortunate because if there's a negative found, it gathers a lot of attention.
And since it's been so long, have studies that were more robust been done and disproven that since then?
Europe put a huge amount of money, several hundred million, into research projects to get a handle on these issues, the questions that you're asking, because they want to know, and there was nothing found. So it certainly hasn't been through a lack of looking.
That's reassuring. Good to know. The next one is allergies.
There's so many food sensitivities and food allergies, and it's due to having these GMO crops.
EFSA does a huge amount of assessment on allergenicity, and it's one of the key parts of the European Commission's requirement for all GMOs.
Say it is approved that there is a GMO potato at some stage, would that have to have allergen testing done before it went to market?
Yeah, so they've put a limit on the number of edits or modifications that can be done. So if it's less than 20, it goes into a conventional breeding stream. So it won't have to go through the current GMO regulation that's there.
Right.
If it's above 20, yes, it would have to go through that regulation, and then it would go through all the allergenicity work, all the compositional analysis work, everything.
And obviously here you're not going to have the transgenic where you're getting stuff from other things, but there was a corn in Mexico that had some stuff from a tomato, some stuff from a carrot, and some genes from a crab. Would that be an issue with people who could have a seafood allergy then reacting to corn?
Possibly, and I mean, if a company grew that and they filled ships with it and they want to sell it into Europe as an animal feed, they can't, because it has to be assessed first. There will be alarm bells going, okay, that's a potential allergen, it's on the list of official allergens, and then they would ask the company who has submitted the dossier, have you done feeding studies? so with rodents or whatever, to show that there is no allergenicity risk or anything like that.
And so obviously that means people here are reassured. What about the rest of the world? Is it just like Wild West for everyone else?
No, in fairness, I mean, the food safety authorities in Australia, you know, they're pretty on the ball as well, I would imagine, and in the US as well. So of course there's different standards and there's different approaches, but ultimately it's about keeping people safe. I can only speak for Europe, and I've had first-hand exposure to EFSA systems and knowledge, and yeah, I mean, it's top-notch.
And then next on the list is antibiotic resistance.
In most GMOs, they put in a gene that's called an antibiotic-resistant marker gene. If the gene transfers into bacteria and creates antibiotic-resistant pathogenic bacteria, we're just spreading this horrible situation right now where we're losing the effectiveness of our antibiotics.
Antibiotic-resistant markers should not be used. Why are they used? They're actually used in the process of generating them. It's an easy way to identify material that has the gene you want. You attach it to an antibiotic-resistant gene, which means the cells can then grow in the presence of the antibiotic. So any dead cells won't have your gene you want, and the antibiotic-resistant cells will. But of course, there's a collateral issue. You don't want the antibiotic-resistant gene there either.
So what do you use instead? Because obviously that's very useful for filtering out the ones that have worked.
Yeah, exactly. So there's two ways to come at it. One, you make your process much more efficient, so that, you know, if you do 100 bits of plant tissue at the start that you're treating with agrobacterium, maybe 50% of them would be edited or have the cis gene, in which case you don't need an antibiotic resistant gene, you just need an enthusiastic researcher to work through all the samples that are there. The other way is you can use fluorescent markers where you shine a bit of UV light and they go bright green or bright blue. And they're equally effective as well.
There are some people who just say it's meddling with nature, which sounds very simplistic, but then I think if we look at our history of things like in Australia, we introduced the cane toad to get rid of a pest on sugarcane, and then it went crazy, and it's now a pest. Is there a danger of that happening with GMO crops once you let them out in the environment?
No, there isn't. But the thing is, it's a case-by-case study, and that's where those assessments are really important. So, for example, when we did that work 10 years ago with potato, we went out and we said, ask us any question at all that matters to you. So one was a farmer in Donegal who said, how could I guarantee that his potato crop would not be contaminated by the potato crop grown here in Oak Park? To me as a scientist, I was a bit baffled because biologically it's impossible, and the reason why is because potato is clonal. So you put a tuber in the ground, you grow the plant, it sprouts, you grow the plant, and you harvest the tubers from the same plant. So those tubers are genetically identical to what you sowed.
There was a case in Mexico with corn plants. And so obviously that's not a tuber, but there was a case of some of the indigenous corn being cross-pollinated.
Pollen will travel, the majority, 90% might travel for, say, oilseed rape out to maybe 50, 70 metres, maybe less. But you will have a tail off after that for maybe 150 metres. So then what you do is you introduce a coexistence measure which says if you're going to grow, say, a herbicide-tolerant oilseed rape, you need to make sure that it's 200 metres from an organic system. Now, it could be off with my distances, but the principle is the same. You know, there are methods to segregate and to keep things apart.
And is it important then to have, before anything can potentially get contaminated, to have seed banks of those original ones as well, just in case?
Absolutely, and those seed banks are now so important. So, you know, the seed banks, there's one up in the tundra in Northern Europe that's buried in the tundra, basically, in the seed bank. There's one in North America. They're all over the world. And with sequencing, we now are going back in and we're seeing what's there, and we're seeing, okay, well, actually that variety that's been sitting on a shelf for the last 100 years, it was discarded, you know, 100 years ago or 80 years ago by breeders because it wasn't yielding properly. It wasn't meeting the yield expectations. But breeders were chasing yield. Now breeders are chasing traits such as disease resistance, insect resistance, quality. So they're going back and going, well, hang on, that variety was really good for disease X, but now you can use something like editing or cisgenics just to take the gene out.
If you make a plant that's resistant to one type of pest, will that pest then move on to all the native plants? So
in the US there's a lot of insect-resistant maize and insect-resistant crops grown. And what they've seen is that some of these insects will develop resistance to the BT gene. That's not surprising.
You'll see right here, I've peeled back the first ear that was closest to me while we're talking. And what do we have? right there. That is the BT technology not working.
To move to a new host is effectively redirecting its evolution.
Right.
And that's going to take a considerable amount of time. It's much quicker for the pest to actually evolve resistance and actually keep gnawing its way through a plant, but if it's resistant to it, it won't die, so it'll just keep going.
And so with the pests then developing resistance, whether it be a fungus or a actual literal moth or that sort of thing, then is it like in the past you could just change then to a new fungicide?
Yes.
But if it's your plant that's resistant, then do you have to redo a whole new plant? Or are we ending up with GMO crops that are then still getting the same amount of pesticides and fungicides?
Yeah, so no, it's a really, really important question, because what we need to do is integrate different strategies. And it's basically like a pyramid is the structure of it. We should rely more on resistant varieties and less on pesticides. In theory, absolutely, nobody would disagree with that. But the problem is we don't have those varieties. But if you do, then you can integrate everything. So you can have a resistant variety, you can use your biologicals to support it, and if needs be, you can use 1 or 2 sprays of pesticide as a last resort. But as diseases evolve, which they will, which we all accept, which we know, they will evolve against the resistance, whether it's bred through conventional means or whether it's through an established genomic technique or a new genomic technique. They are going to evolve. They're not going to disappear because they've been around for tens of thousands of years.
So going back to the example of a potato then, you would want to see multiple potatoes that are all blight resistant, multiple breeds of potatoes? Is that the idea?
Absolutely, but the key thing there would be the source of the resistance, because all the potato varieties in Europe, pretty much all of them have very low resistance to late blight anyway. So if you, let's say the doomsday scenario, you introduced a single gene of resistance from a wild potato and it ended up in all the potato varieties in Western Europe, of course it's going to be attractive to farmers. So they're all going to grow it. If you have a single source of resistance, you are gambling and it will break down over time. So that's why you need multiple layers of resistance, and you need multiple strategies, again coming back to IPM.
And one of the other things that people are concerned about is what if there's an unknown consequence? So you're making it resistant to this, or great for this particular purpose, but it's having an unknown. So I think like the BT cotton in Africa had it had high yields but lower weight of the cotton, and the length of the fibres wasn't as long. What if with our food there's some unknown consequence that we don't know, we don't notice?
So there's an element in for evaluating a transgenic GMO, there's an element of exploration for unknown consequences. So they run through a battery of tests. The important thing to point out though is that this happens in conventional breeding all the time. So when you cross 2 varieties, as I said, you're getting a complete mix of genetic soup. So you will have material there that might taste great, but you have a smaller apple. Or you have a bigger orange but it doesn't taste as sweet as you had before.
And then the other thing linked with, I guess that with everybody wanting to grow something, if it's resistant to blight or it's good, is the patenting of that sort of structure. And does that lead to, I guess, a monopoly on the food? If a few companies that have the know-how and the money to be able to develop these sort of foods, do they then own the food supply essentially?
So they wouldn't own the food supply, but obviously they would have a call on the original resource. So this is the big topic of discussion in Europe at the moment. They haven't worked out how to get through that. The new regulation is saying that, look, if there's a patent on a genetic resource or the use of that resource or a technology, the breeder just needs to deal with the patent holder. Okay, and then the breeder then, as a breeding company, would release the variety out to farmers, and it's sold and it's grown and it goes into the food chain, etc. The thing with patenting is that obviously, we hark back 20 years ago and there was nightmare stories and nightmare legal cases about all of this sort of stuff, and that was built on a model of a company that had a particular technology, but they also had a particular product that was matched with that technology, and then they wanted to contain the use of the seed within the people who were growing it. The thing is that's pretty much the way it is if you buy certified seed now. Conventional farmers, you sign an agreement that you'll grow it and you'll sell it on to a particular merchant. Okay, if you're going to farm save it, you can't hand it on to anybody else. And Why would you do that? Well, you're doing that because you're getting the best seed. You're getting the top quality tier 1 seed. It's certified to germinate really quickly at a very high percentage. So you're ultimately saving money, because rather than getting something that germinates at 70%, you're getting something that germinates at 98%.
So why the concern then, do you think, that people have with a monopoly? Is it the shift of who owns that seed that's the issue?
One element of that is a lack of awareness of what we already have. And I think that's probably one of the other issues around GM, is that maybe people are not as aware and familiar with current production systems that we have at the moment and the problems we have with them.
And as far as patenting seeds, to put it on the other side of the people who are developing them, what is the cost that it would be to develop?
You can cut the breeding time, say for potato, from say 13 years down to maybe 6 years, 7 years, so you're taking a sizable chunk out of it. If you compare it to what you do for conventional breeding, and you look at all the time, personnel, the logistics, the materials and everything else that goes into there, I would be surprised if they're not equivalent or is cheaper.
The debate of labelling is huge in the US,
yeah.
like from people who are saying it's a waste of time, it shouldn't be on there, to people who are saying I have to be able to choose, it should be on there.
Yeah.
Any idea what's going to happen here?
If the regulation in Europe proceeds as expected and anticipated, material generated using cisgenics or editing is equivalent to a conventionally bred variety. I don't see a need to label it if it's already considered a conventional technique. That's
and in your opinion, if it was from other species, would you like to have that labelled on products?
Studies have shown that people want to know what's happening with that. Yeah. If a consumer wants to know about it, they should be directed towards an information source that will help them with it. That's a discussion that people way above my pay grade have to sort out in Europe.
Thank you so much for your time.
Pleasure.
Answering all of the many questions that come up with GMO.
Thank you, and thank you for coming all the way. It's great to have the chats.
And with thanks to you, my subscribers, and a special thanks to my patrons for all of your support. Let me know what you think about the whole GMO debate. Make it a great week by being kind to others, and I'll see you on Friday.